Today we will talk about one very important theorem, that is Gauss theorem. In the previous video I was discussing about area vector, and we were trying to understand what is the importance of area vector in physics, and I was trying to connect the area vector with the flux, electric flux. Now, if you understood that concept of area vector, then please go through this sentence. The Gauss theorem says that the surface integral of the electric field intensity over any closed hypothetical surface called the Gaussian surface. Now, what is Gaussian surface? Gaussian surface is an imaginary surface which is uh, it is closed surface and it is imaginary. Now, the surface integral of the electric field lines over any closed hypothetical surface, Gaussian surface in free space is equal to 1 pi epsilon naught times the net charge enclosed within the surface. Means, what is this? The surface integral of electric field, it is equal to 1 by epsilon naught times the net charge enclosed by the surface. इस चीज को ध्यान रखना है. Now I can write like this. How? What is phi here? This is electric flux, and what is this E dot ds? So this surface integral. This, according to the theorem only, we have written mathematically vector E dot vector ds. Now vector E dot y vector ds, because it's a dot product. Yesterday we in the previous class we had discussed about it. So now this is equal to what? This is equal to, according to the definition, equal to 1 by epsilon naught times the net charge. So this is 1 by epsilon naught, and summation of Q1 means it is the net charge. Whatever, suppose I have one enclosed surface and I had kept charge inside, say 1 coulomb, and Gaussian surface is, I had imagined one Gaussian surface around it. Now when I had imagined Gaussian surface around it, how much is that net flux, total flux, according to Gauss theorem? So take the whole surface. Now let us prove it. How to prove it? Let me take one spherical surface. This is spherical surface here, and let me uh, center is at O, and the charge inside the spherical surface is say plus Q. Let me take a small area here. This is a small area, and this area is say ds. Okay. Now electric field, the direction of electric field is this way. Okay. Why? Because electric field lines, suppose this Q, so what will be the direction of electric field for Q? It will be all around this, like this, like this. So here at this point, if I take the direction of electric field, what will be that? That will be this side. And this yellow line, the yellow arrow shows the direction of surface area, the area vector. How the area vector? The area vector, surface area is this much. So how the area vector? Yesterday in our class we discussed that. Now the angle between E and ds. See, I had written Gauss theorem here. D phi equal to E dot ds, and that is for E, what I am writing, 1 by 4 pi epsilon naught Q by R square. Okay, this has come from the formula of electric field strength. Now R cap, what is R cap? R cap is the direction of electric field. This is R cap. This is the direction of electric field. And ds n cap, what is ds? Ds is the area vector. Ds is the area vector. And what is n cap? N cap is the direction. This direction of what? Direction of the area, surface area vector. Now if I rewrite this, it will be d phi equal to 1 by 4 pi epsilon naught Q ds by R square. Okay, Q ds by R square. R cap dot n cap. This is R cap dot n cap. And what is the angle between R cap and n cap? This is R cap and this is n cap. So what is the angle between these two? Angle between these two is 0. So it will become, and it's a dot product, so it will become uh, r cap dot n cap equal to 1 into 1, that is cos 0 degree, that is becomes 1. So now what will be d phi? D phi will be 1 by 4 pi epsilon naught q ds by r square from here. And again I can write this d phi as 1 by 4 pi epsilon naught q by r square, and I am integrating ds. Why I am integrating ds? Because this is the flux due to only this surface. This the flux only due to this surface, and if I want total flux of the whole surface, then I have to integrate the whole surface. So for the whole surface, so it will become 1 by 4 pi epsilon naught q by r square, yahin se q by r square. And if I integrate this surface, small surface ds, so I'll be getting 4 pi r square. What is 4 pi r square? 4 pi r square is the total surface area of the sphere. Now if again I rewrite, I will be getting 1 by 4 pi epsilon naught is here, and 4 pi r square is here, and q by r square is here. So 4 pi and 4 pi will cancel, and r square also will cancel, and what will be left? It will be q by epsilon naught, and this is q by epsilon naught, and this is the proof of Gauss theorem. This is a very important theorem, and please try this and try to practice this theorem. Thank you.